Hello students, this is Professor Atul Kumar Srivastav from SIIT Excellence College, Sage Group. Today we will discuss the subject Advanced Computer Architecture, and which we will discuss the topic Nonlinear Pipeline Processing. So as we know that linear pipeline processing and nonlinear pipeline processing, there are two types of pipeline processing. So if we want to display or we want to execute the single task in multiple parts, then the nonlinear pipeline will be used for that. And the part of these tasks are fed into the pipeline, and the execution will be um, execution will be simultaneous, means the parallel execution will be there. So parallelism can be achieved with the help of the nonlinear pipelining execution. So let's we start. Nonlinear pipeline efficiency can be used, or it is the stage utilization is defined as the percentage of time that each pipeline stage is used over a sufficiently long series of task initiation. The accumulated rate of all stage utilization gives the pipeline efficiency. The pipeline efficiency can be calculated with the help of this formula, that is pipeline efficiency equal to number of checked blocks divided by number of total blocks. So these blocks we have to find from the reservation table. So here we are looking in the given diagram that for latency cycle 3, we looks that there are four part in which the efficiency can be calculated, because it is showing that maximum efficiency is there. So firstly, we are taking from 6 to 8 part, so in which the latency is 3. So it is looking that the occupied blocks are 8 and the total blocks are 9. So pipeline efficiency can be represented with the help of this formula, that 8 divided by 9. Similarly, if we are looking at the column number 12, 13 and 14, so similar condition is there. The occupied blocks are 8 and the total blocks are 9. So same answer will be there. Number of checked blocks is 8 and the number of total blocks is 9. So that is represented in the efficiency of the pipeline. Now we will discuss the next topic, that is the instruction pipeline. So the instruction pipeline can be represented with the help of the 4 sequence of operations like the fetch, decode, execute and write back. These all operations execute in a linear pipeline processor in an overlap manner, only if no dependency exists. If dependencies will not be there, then they can be executed simultaneously. But if the dependency is there, then the overlap it cannot be executed in overlapping manner. So due to the different types of dependency, a lot of pipeline clock cycle gets wasted. So this is the example in which we are looking that instruction pipeline is executed in these steps. So the total 7 clock cycles are involved in it, where F, D, I. F is the fetching, D is the decoding, I is the issuing, E for the execution, and W for the write back. So this is the example in which the memory space contents of Y is loaded into the register 1, R1, and the memory location content Z is loaded into the R2. So if we are adding the R1 and R2, then the R3 can be achieved. Here is a problem that the R3 result of the R3 is dependent on the R1 and R2, and definitely it will cause for the delay of the result. So to minimize this delay, or to ideal condition, we have to use the R1, R2, then R4 and R5, because there is no dependencies if we are using in this sequence. So if we are changing the sequence, then definitely the ideal condition of the processor can be minimized. This is the way by which, if we are using the previous sequence, this sequence if we are using, then this is the way in which we are looking that there are so many instruction cycles are wasted here. But if we are changing the sequence, this is the way by reordering the program execution, we can improve the performance of instruction pipeline up to an extent. So this is the way by which we can extend or we can improve the performance if we are changing the execution sequence. So first is the R1, second is the R2, third is the R3. That should not be there. Then we will use the R4 and R5 instead of the R3, and that we changes the sequence and we can achieve the improved performance. So that is the way by which we can improve the instruction cycle performance. Mechanism of instruction pipeline is prefetch buffer, multiple functional units, and internal data forwarding. So prefetch buffer is there are three types of buffers can be used: sequencer buffer and the target buffer, loop buffer. These type of buffers can be used to store the data. This is the example of different types of buffers: sequential buffer and target buffers. The multiple functional units is used to remove the bottleneck problem, and that can be minimized with the help of the multiple copies of the same state simultaneously. So in this way, we can represent that how the multiple functional units can work. Now, internal data forwarding is a concept that if we are using the load and store and load forwarding mechanism, then there is a need of two operations. But if we are converting the store and load operation with the help of the move operation, then the different registers R1 and R2 can communicate with each other, and there is no need of accessing the memories frequently. Similarly, it happens in load forwarding mechanism, where the two in as we are looking in the figure B, that two times the load operation is required. But if we want, then we can remove the second load operation, and it can be replaced with the help of the move operation. So that is very beneficial. So store load forwarding, a load operation from memory to register R2 can be replaced with move operation from R1 to R2. Load forwarding, second load operation is replaced with the move operation. So that is complete. So thank you very much to all. I hope it will be very beneficial to you. Thank you very much.